This is a full wave center tapped transformer rectifier. We are going to derive a formula for the peak inverse voltage PIV across D1 or D2. Earlier on we have discussed during the positive half cycle, D1 is forward biased and current go through D1. D2 is reverse biased and no current can go through D2. And D2 will have its peak inverse voltage across it when the voltage across the primary coil of the transformer is at its maximum value. That is this one, maximum value. At this moment, the voltage value at this point will be at the maximum too, which is this value, half of the secondary coil voltage. And at this point, the voltage will be at its minimum. Again, the magnitude is half of the secondary coil voltage. But because the ground is here, the minimum value here is a negative value. Since D1 is conducting, there will have a voltage drop of 0.7 volt from here to here. So the voltage at this point can be calculated by this value minus 0.7 volt. That is this one. This is the low of the circuit. So this is the output point of the whole circuit. So we can say the peak output voltage is given by this formula. And this voltage is also the voltage here. And this is the peak output voltage, while here is the minimum voltage at this point. So the difference between this one and this one is the peak inverse voltage across D2. That is this expression. Since this circuit is symmetrical, the peak inverse voltage at D1 during the negative half cycle can also be derived to be this same formula. Let's simplify the expression we have just written down. Minus and minus become addition. So half of the secondary peak at this half of the secondary peak will become 1 secondary peak minus 0.7 volt. And early on, we know that this is the peak output voltage. And putting this 0.7 volt to the other side will become plus 0.7 volt. And multiply this whole equation by 2, we can have this equation. So we substitute the V secondary peak here with this expression. So we get peak inverse voltage equal to this. There's a V secondary peak minus 0.7 volt from here. Simplify this equation, become a formula. So we have finally come to this formula. Let's see an example to apply the formulas we have found. The peak value of the voltage across the primary coil of the transformer is given to be 100 volt. We are going to find the peak value across the secondary coil. And then we go and find the peak value of the output voltage and the peak inverse voltage across D1 and D2. So all this can be found from formula. The relationship of the peak secondary voltage and the peak primary voltage are determined by the turn ratio. This one. While it is given here 2 to 1. So the secondary coil has less number of turns. So its voltage will be lower than the voltage across the primary side. The ratio is 2 to 1, so if here is 100 volt across it, here will be 50 volt only. So we get this calculated. For the peak output voltage, just simply apply the formula we have derived, and we get this answer. For the peak inverse voltage across either of this dial can also be calculated by this formula. And this peak output voltage already been calculated here. Substitute in, then we can find the final answer for the peak inverse voltage.